like a maybe. I like that, Lucas. You're putting yourself out there. All right. So there really are a couple different formats for parabolas, and I should start there. One of the parabola formats is what I would call polynomial format or standard format, and that's what you guys are used to. Okay, you guys are used to that because that's where we pull A, B, and C for the quadratic formula. That's a polynomial. There's another format, though, that is arguably more powerful, and that is something that looks like this. I'll call this one standard or polynomial, and I'll call this one vertex format. Just like lines have a couple of different formats, there's like slope-intercept format, point-slope format. Parabolas, and by the way, these will be 2 flashcards. Parabolas have 2 formats. The A, in both cases, means the exact same thing, should be the exact same number. The B and C over here obviously play into the quadratic formula. The C is your y-intercept, so that's kind of helpful, right? When x is 0, that C value will be your y-intercept. Over here, since it's called vertex format, the HK is your vertex. So what's nice about this format is you just look at it and you can pull your vertex, HK. Whatever's in the H spot, whatever's in the K spot, that's your vertex. Versus if you want to find the vertex from this format, what did we learn yesterday? You have to calculate. Negative b over 2a, right? So you have to do a calculation here to find the vertex. Find your negative b over 2a, then plug it back in. Then you have your vertex. Here, if it's in this format, it's right in front of you. What I also like about this format is that this one is an elaboration off the parent graph, where it's been shifted right h units. Do you see that? It's been stretched or compressed vertically by A, and it's been shifted up k units. Okay? Right here in your parent graph isn't your vertex 0, 0. But if you do x minus h, you've shifted it right h units, so your new vertex would be h, and you've also shifted it up k units, so your new y-coordinate would be k. So it plays into our transformation stuff too. We'll talk more about that. Okay, let's jump into the first one. That's your background. So here we have a function y equals x squared, already shown. There's your parent graph. And we are considering this. This is right now in standard form. I'm going to show you how to change from standard form over into this better, for transformations anyway, vertex form. Okie doke. So first of all, rewrite this more clearly. Okay. The first thing I do is get rid of the 18. So I'm going to subtract that over. And thinking back to our special factoring and our special trinomials, I'm going to try to figure out what can I add here? What number would I add that would make this a perfect square trinomial? Remember your perfect square trinomial pattern where this is a perfect square? This has to be a perfect square. And the square root of them multiplied together and multiplied by 2 should get you to 8. Raise your hand when you think you know what that number should be. I'm going to say what I said one more time. The perfect square trinomial pattern, this has to be a perfect square, and this has to be a perfect square, such that the square root of this one times the square root of this one doubled will give us that. 1, 2, 3, 4, 5, 6, 7. Wow. Alyssa. Wait, are you not Alyssa? Alexa. Sorry. I'm sorry. You know, I get myself by doing alphabetical order. Like, and Alyssa sits there like 3 times out of my day. And then Alexa comes in and surprises me. She's right. 16. Yes? How did you get that, Alexa? Right. Essentially, here's what you do to go for. She thought backwards, right? If you want the shortcut, what you do is you take this number, that's your B term, right? You divide it in half, which will be what? -4, right? And square it. And -4 squared is 16. Now, I'm going to write that on the side. You take B, cut it in half, and then square it. That's what that is. Now, just like any equations, you can't add 16 to one side without... How do you have to make sure things are still going to be equal? If you add 16 to one side, you have to add 16 to the other side so that it all still stays equal. So now we have y minus 2 equals, and now that we made this a perfect square trinomial, we're going to factor it. What does it factor into? Jack B. Everybody should be trying to factor that. So when Jack B gives me his answer, and I ask you whether or not you agree, Jason, you're going to say, with confidence, yes or no, God bless you. Do you need water? Did you factor, Jason? What'd you get? Very good. Jack B, did you hear him? What did he say? Yep. It's x minus 4 times x minus 4. Now, by the way, it's a perfect square trinomial. We wrote it that way. We made that happen. So whatever we factor it to, it's going to be something times itself. Yes? That's what a perfect square is. So we designed it that way, put the 16 there. If you were looking for a shortcut for that factoring, whatever that half of b was, -4, that's going to be your magic number. And then all we do from here is add this 2 back over to the end. And there we go. So, what number, now be careful, I'm going to rewrite the Vertex format underneath. What's my A value? Angie? Here's the format. Here's my equation. What number is in place of my A? 1. And that is the same A that you have in standard form, by the way. That will not change. Okay? What is in place of my H? Lucas B. What's that? And this is where it's tricky. It's not -4. The negative is a part of the structure. So that negative is a part of that. H is just 4. Okay? And K is 2. Yes? So your HK is 4, 2. That's where the vertex of this parabola is. So what happened to the original parabola? It got shifted 4 units to the right and shifted up 2. So we're going to take this 4 units to the right, up 2. We're going to do that with every one of the critical points. And there's our new shifted parabola. Just for the sake of showing you how it's the same no matter what. If you were to find the vertex from standard form, -b over 2a is 8 over 2 is 4. There's your x coordinate. You plug 4 back in, you're going to get 16 minus 32 is negative 16 plus 18 is 2. There's your vertex, same vertex we got from completing the square. Follow? So you have to know how to do it either by the completing the square method or by finding negative b over 2a. Common Core is very crafty about asking it in such a way that you couldn't just avoid one of these techniques. Okay, you have to understand both. So describe how the graph would be shifted. We already said this. Right 4, up 2. We already said the points of the vertex were 4, 2. Okay, exercise 3 down below. We'll do 3A. What do you notice is a little bit different about this one versus the last? You notice anything, Lucas? This is dangerous if you don't pay attention and aren't careful right from the get-go. We're still going to add this 2 over. I'm still going to get rid of the 2. But here's the tricky part. You can't complete the square when there's an a value other than 1. Meaning I can't just jump right in and divide 12 because there's no way to make this a perfect square trinomial. 3x squared is not a perfect square. So I can't do it with the 3 there, so I have to actually factor it out as a GCF. Which changes it to that. And I'm not closing my parenthesis on purpose because I need to complete the square on this portion. Do we follow? It would be, but I need to keep that perfect square trinomial factor. So I want to keep the x squared as my first term, keep the x and then this last term will be a constant so that I'm making a perfect square trinomial. Does everyone see what she just asked there? I only take out the a, in other words. So I guess you're right. I don't technically take out the GCF. I divide out the a, whatever it is. Even if it didn't work out nicely with 12, I still take out the a and divide it out. So if that becomes a fraction, so be it. I still take out the a. I haven't seen it too often where they're nasty like that and they make it a fraction, to be honest. But so now just focusing on the trinomial, raise your hand when you can tell me what's supposed to be added there. Remember our rule. You take half of b and you square it. Natalie, what's your guess? Where are you getting 36 from? 12's not our b anymore, dear. 4. Half of b is 2. Squared is 4. Here's the tricky part. On top of we had an extra step in there. I added 4. But I added 4 in a set of parentheses that's being multiplied by 3. So what did I really add to the right? 12. You see that? I added a 4 in a set of parentheses that's being multiplied by 3. I really added 12. So when I keep things balanced, I add 12 to the other side to balance that. This is one of those things where it's going to be kind of hard for you to look back at your notes and remember what we did because we're kind of filling in blanks here. So you might want to rewatch this video if you have a moment on your homework and you forget all this. So y plus 14 equals 3, and then this is going to factor into what's squared. I'm going to you, Jack B, because I let you off the hook last time. X plus 2, perfect. And then I bring my 14 over. So, what is my vertex test? I'm just going to write and line this up underneath because I think it's easier to see. What would my h have to be so that minus the h would turn into plus 2? What's going to make the minus sign turn into a plus? Someone help her out. Owen? A double negative. So h is actually negative 2. Minus a negative 2 is what would make that a plus 2. So you have to get used to that when you're pulling your h. You're really pulling the opposite number of what you see. So the vertex is negative 2. By the way, you know how like plus 2 means actually left 2 and it's backwards? This is why. Because of this funky thing. So, and k is what? Try that test. Nope. Negative. So with the h, you take the opposite of what you see. With the k, you take exactly what you see. Is that clear? So plus what would make negative 14? Negative 14. And the a value, of course, is 3, and that was 3 right from the get-go. Let's see. Jump to 4 on the back. This is like, you might read this and be like, well, how does this pertain? This is asking for the function is strictly decreasing over what interval? So here's the thing about parabolas. Prior to the vertex, they're doing one thing, increasing or decreasing. And then after the vertex, they're doing the opposite of what they were doing, right? You increase into a vertex and then you decrease, or you decrease into a vertex and then you increase, right? If you have an a value that's negative, does this open up or open down? Open down, right? Because the paragraph opens up and a negative out in front flipped it. So if it opens down, and what's our vertex here? Chris Brooks, what's our vertex in this one? If I were to label this. 617. So this is increasing from negative infinity to 6, and then it's decreasing from 6 to infinity. So it's strictly decreasing over what interval? Nope. Number 1. It's decreasing when x is greater than 6, yes? Right? From 6 to infinity if you were doing interval notation. Number 15, truthfully, I would probably just do negative b over 2a. If it doesn't force your hand, why not just do the negative b over 2a method there? In 16, they're giving you all of the new potential vertex formats. So you can complete the square on that. And 21, you don't know how to do yet, so that is actually tomorrow. Yeah, so don't worry about 21. Are there any questions? Oh. Elena has my math term. So. Oh, okay. I think 20. I think raw it was out of 15, 16. So they were 4 points each. Yes, that's it. They were 4 points each. So raw it was out of 16. And so the scaled version I made it out of 20. So everyone got 4 out of 20 points for free.